Welcome back. We're going to actually do the last part of our chapter 2, which deals with what we call a Van de Graaff generator. So, what is this Van de Graaff generator? So, we have learned a lot about potential and capacitors and all that. But what is this new thing called as Van de Graaff generator? So, the Van de Graaff generator that I am showing here is actually very, what do you call, small lower end Van de Graaff generator, which actually has, you can see, generates about 500,000 volts by doing a very small, extremely small voltage that you give it to run a small motor inside, and it will actually generate 500,000 volts. So that is the beauty of this Van de Graaff generator. In fact, the Van de Graaff generator is basically used to generate even millions of volts in a bigger form. In the sense that it will even you can go up to the breakdown of the air. Okay, so in the sense that it can conduct and discharge if the surrounding air, depending on the air, and if air is very dry, you can go up to very high voltage. So how do we generate that kind of a 500,000 volts or a million volts or something like that using a very small battery and this kind of a doom? And what is the use of it? Is there some? It's also a lot of fun using a Van de Graaff generator. If you actually go and touch the Van de Graaff generator like this, and standing on, not on the floor, but with a nice rubber shoe which doesn't conduct. Now, if you go and stand and touch it, nothing happens even with the 500,000 volts. Okay, you're going to basically your hairs stand like this. So all the charges flow to us, a huge amount of charges, and go through the edge, each one of those hair, and go out, discharge. So they also, you can see a lot of sparks using Van de Graaff generator. You can generate a lot of sparks. So you can see that basically you can take one small wire here, you can see, and connect it to the metal here, and don't touch that, and don't allow that the charges to go through you, but go through a wire. So you can actually get, when you go near to this, you can see the blue sparks flying here. So that is all the charges that are flying, electrons, and all that by using very small battery to make such a huge voltage. So how to do that? I mean, there are a lot of other applications wherever very high voltage is required. Van de Graaff generators are used to generate those kind of voltages, and you can also play with it a little bit like this. So you can see that in a Van de Graaff generator, you can play balloon. Okay, this is a metal balloon. If this is very highly charged, okay, to very high volt, lot of charges are there in this. So the moment this metal balloon touches this, it transfers a lot of charge to that. So the moment, let's say this is positive charged, and it goes to the metal balloon, which is also now gets positively charged and gets repelled and goes to him. So when it goes and touches him, it charges him with the positive charge. Now that is positive and this is positive. So it gets repelled here and then comes towards this side. Yeah. So like that it keeps moving between these two. So this is the the charging and discharging. Charging, discharging keeps happening on that when it is moving. So it's a fun to play with. Now we're going to basically see how to actually design this. How is it possible to design such a Van de Graaff generator? How do we generate this? What is the way to do this? So let's just see how to do this. I'm going to draw the picture for that. So when you want to talk about potential of a shell, okay, a spherical shell, we talked about that. So let's say there is a spherical shell. That is the doom of our Van de Graaff generator, the top one. So let us say this is my shell, okay, and if I am able to continuously make charges go onto this and stick. So if I am able to keep on charging this as much as very high amount of charge, let's say I'm going to put lots of positive charges on this. I keep putting more and more and more and more positive charge. So then this will become, this will then hold that much of charge, if you can put, okay, so much of charge. So one difficulty is this, okay, to put a charge into something, you must make the charge flow from somewhere else to this. Okay, let's say I try to put some charge onto this. Now it will actually charge, you have seen even the capacitor, it will only charge up to the main voltage, that is basically from where you are charging. Suppose you are charging with a 100 volts battery and you connect it to this. So it can charge up to 100 volts, and the amount of charge, whatever you can get for the 100 volts, that much. After that it stops charging, it stops the amount of charge on it. So how do you make sure that you keep on charging? So for that it looks as though that we should keep on increasing the voltage to very high volt. If you want to charge up to 500,000 volts, you need something which is 500,000 volts already. That is the view we have. But there is a nice technique here to be able to do this, okay, to charge this without actually worrying about that. Okay, let's see what is that technique. Now assume that the charge on this outside sphere, okay, is plus q. Q is the charge, and from the radius of this, assume, is capital R. Okay. Now we know that if you put if you put Q on this and charge R is the capital R is the radius, what is the potential on the outside surface? So I will call the potential on the outside surface as V of R. Okay, potential on the outside surface. How much is that? So we know the formula. So we have figured out, basically it behaves as though the charge is all accumulated at the center. Okay, that is how the shell behaves, which is nothing but Q divided by 4 pi epsilon naught R. It is the total amount of charge, total amount of voltage, the potential on the surface. Now assume that I am going to put another small sphere, okay, not the circle actually, sphere, okay, here in the middle, another sphere, shell, small one, spherical shell here, and that also I will charge as some positive charges. Let us say this radius is small r. So this radius is capital R and this radius is small r. Now let us see what will happen. Assume that I am able to keep that in the middle by using some insulator connected to this. Okay, hold it up like that. So now what is the potential, okay, at this point due to this? So for any spherical shell, if you want to find out the potential far away from the sphere, then you can find it out as though it is a point charge located at the center. So the potential for this due to the small one is actually Q divided by 4 pi epsilon naught capital R, because I want to find out the potential on the surface of this. On the surface of this means the distance is capital R. So what is the charge? Charge is small q. This is small q and this is capital Q. Both are plus. So potential on the bigger sphere due to the plus q charge on the bigger sphere is Q divided by 4 pi epsilon naught capital R, and potential on the big sphere due to the small sphere having a charge of small q is small q divided by 4 pi epsilon naught capital R, because the distance is still same. Now if I want to say what is the actual potential on that, this is an addition of these two. Okay, so that is the potential on the outer sphere because of both the spheres. Let us look at what is the potential on the inner sphere. Inner sphere, V of small r. So what is the potential of this on this due to the charge that is on this? So we know that inside a spherical shell potential is constant. Okay, that's not going to change. So that is same as what is there on the surface. So which is nothing but Q divided by 4 pi epsilon naught R, capital R. This is same as that. But is this the correct Q? Divided by 4 pi epsilon naught R. Correct? This is basically due to this. Due to this. Okay. Now what is the potential on the smaller sphere due to the charge that is here, smaller sphere? That will be simple. That will be small q divided by 4 pi epsilon naught small r. If you add these two, that is the potential on the smaller sphere. So we are able to find the potential on the outer sphere, potential on the inner sphere. Okay, so just go through it once again in your mind why we do these things. This is actually because on the surface of any sphere, on a spherical shell, you can calculate it. Okay, on this is because this is from the smaller one, and anywhere away from the smaller one, smaller sphere here, you can calculate as though it is at the center. Okay, so those two are, we have similarly for the smaller one, because this part is constant inside fully due to the bigger sphere, fully inside you have exactly the same potential which is on the surface, which is the same as this. Okay. Now we will find out the difference between these potentials. That means I'll say VR minus VR. So from potential in the inner sphere minus potential in the outer sphere. Okay. If you take that, that would be equal to, okay, this will get cancelled. This is nothing but Q divided by 4 pi epsilon naught into 1 by small r minus 1 by capital R. This is the potential, and you can see this. The small r, okay, has a smaller value than capital R, which means basically this one is bigger than this, and this thing 1 by r minus capital 1 by capital R is positive. Okay. So always this potential difference is positive. That means the inner sphere is at a higher potential than the higher sphere, outer sphere. And the surprise part is this: even though the value of capital Q is very high, you can put it with as much charge as you want to put on that. Even then, this is at a lower potential than this. So very surprising thing. This is the beauty of this. Okay, suppose if you can actually connect, let us say, some wire from here to here. Okay, that wire will conduct a current like this. Always, how much ever may be the charge, capital Q, it is still the outer sphere is at a lower potential. Outer sphere is always at a lower potential. Than inner sphere. That is the trick. The trick is that outer potential is always at a lower potential from the inner sphere. Suppose if we can pour charges from inner sphere to outer sphere, we can keep on pouring and pour and make it very high. This plus Q, capital Q, can become very big. We can keep on pouring, and hence you can actually create a lot of charge on this, and hence you can make potential between this and the ground elsewhere. Ground means basically the earth can be very high, 500,000 volts, like that. Okay, million volts, like that you can create. So that is the idea of a Van de Graaff generator. This is basically created by Van de Graaff generator, some scientist. So that is the idea of this. So practically, how do we do it? How do we actually take charges from here and pour onto this? So that is basically the engineering part of the design. So let me show you the schematic of that, an engineering part of the design, so that you can actually write down that and practice it. That sometimes comes in the exams also, and you will get an idea of how it is done. Okay, so I'm going to basically show you how to how it is basically constructed. How it is constructed. Okay, this is the picture. This is also a textbook picture in a sense. So you can actually look at this. Uh, Two different spheres. Okay, this is the external sphere. Okay, that is this outside sphere, and this one is the internal one, smaller sphere. This one. Okay. So what you do is, this is a metallic one. This is also internally. So now you're going to basically have internally, okay, one insulated like a rubber or some kind of a silk belt which is going over this on a pulley. There are two pulleys, one pulley here, one pulley here. Okay, and using a motor you can rotate it. So when it rotates it, basically this pulley, one pulley if you rotate, the other one also will rotate because of the belt kind of a mechanism here. The belt made up of either a rubber or a silk insulating one. Now what we do is actually, you from outside using some kind of a metal comb which just touches this. Okay, it's like a brush comb that touches this with lots of sharp edges here, and we're going to pass on certain positive charges from a small voltage. Positive charges, those positive charges get deposited. Okay, so please understand this, whenever we say positive charges, it does not mean that it may even mean that getting the electron out of it. Okay, so sucking the electron is also mean putting the positive charge. Okay, so ultimately you put positive charges on this belt. Since it is rotating, the positive charge, the belt doesn't conduct. Since you rotate it, positive charges go up here, like this. See the arrow. So and when they go up here, you can see uh, these charges basically go in this area. Okay. Now what happens is that there is another metal comb that is basically between these two. Okay, and that one will make sure that the charges which are here will move to the external sphere. So when it always keeps going, because this internal one, okay, is always at a higher potential than the external. So that we have proved here. Internal one is always at a higher potential than the external one. So outer sphere is always at a lower potential than the inner. Because of that, it continuously keeps sending these charges here. The charges get poured onto the external sphere, and it keeps as long as you are running this motor, it's basically just pumping in the charges into that, and it will accumulate on the top of it, and hence the Van de Graaff generator can actually take a huge amount of charges. Okay, so you will be asked to explain the working principle of the Van de Graaff generator, in which case you have to first of all prove it, saying that how an internal, using the shell, in a spherical shell, potential on the spherical shell, using that you have to show how it is external one sphere is always at lower potential than the inner, and then you can write the schematic and explain the working of that, the rotation, whatever I explained. So that actually completes our Van de Graaff generator, and we have completed the chapter 2, which is basically potential, electrostatic potential, and the capacitors. Okay, thank you.